From Microbe TV, this is TWiP, This Week in Parasitism, episode 201, recorded on December 2nd, 2021. I'm Vincent Racaniello, and joining me today from Fort Lee, New Jersey, Dixon Despommier.
Hello there, Vincent, Christina, and Daniel. It's dark outside, so I can't tell you what the weather is like, but it was a typical winter day, and it was. It continues to be a typical winter day, so hello, everybody.
Also joining me here at the incubator in New York, Daniel Griffin.
Hello, everyone.
Daniel's actually right next to me.
Yeah, I think we can reach across with my broken arm. So, yeah, just for the people watching us on YouTube.
Fun to record here. And also joining us from Glasgow, Christina Naula. Welcome.
Hi everybody. It's good to be here.
Hello, Christina.
Here we are with TWiP 201. We're getting into the next 100. And it is time to address our last clinical case. Daniel, why don't you update us?
Sure. So we are talking about a man in his 30s with known HIV/AIDS who presented with lower extremity weakness, headache, fever, ends up in the hospital. We get a little background. He lives with his wife and her cat, not his. He does not take his medications. His CD4 count is less than a 100. He was told to take medicine every day, one pill 3 times per week, one weekly. He's not doing this. Does not drink alcohol, only eats well-cooked meat. That actually turns out that is a religious issue. He is born and raised in San Juan. He does report multiple sexual exposures with multiple women over the years. He reports a thin coating on his tongue, which actually we see as well. His lungs are normal. His bowel sounds are normal. His exam is really significant only for this weakness in his lower extremities. Skin exam's unremarkable with no rashes, but there is a CAT scan which shows multiple ring-enhancing lesions with surrounding edema. We're also seeing similar findings on brain MRI.
Dixon, could you take that first one?
Yes, I can. So here comes the guesses. Tiz writes, the case presumably could be a space-occupying lesion in an immunocompromised patient with a history of keeping cats as pets. Most likely is toxoplasmosis.
Christina.
Michelle writes, hello TWiP team. Thank you for the fun parasite chat. It's 84 degrees Fahrenheit, which is warm even for California in November. This gentleman presents with health concerns complicated by HIV. His symptoms, lower limb weakness, fever and abnormal CT MRI with edema. His parasitic risks include living with a cat. Although there are no skin lesions like a scratch mentioned, he could have cat scratch fever transmitted from the scratch or bite of the cat or fleas infected with Bartonella henselae. This is compatible with headache and one of the feline zoonotic diseases that does not cause any GI distress symptoms. It sounds like a course of antibiotics would be in order. I'm not sure if this can be identified by blood culture, but the history of a cat and immune-compromised condition are suspicious. Cheers to many more TWiP intrigues.
Daniel.
Alexander writes, Dear professors, the patient with HIV/AIDS and ring-enhancing lesions on brain MRI most likely has toxoplasmosis, which he may have contracted from the cat or possibly many years ago from raw meat. Differentials include neurocysticercosis and several non-parasitic entities, including CNS lymphoma, metastases, embolic abscesses, TBC, and demyelination. Due to his HIV infection, the patient is at risk for most of them and needs antiretroviral treatment ASAP. Brain biopsy may be required to make the diagnosis, but you could empirically treat with sulfadiazine, pyrimethamine and leucovorin and monitor closely. I hope you will get this email. I've already sent answers for the last 2 cases, but they didn't make it into the episodes. I hope I didn't send them too late. Thank you for the great case and all the best, Alexander from Vienna.
You're next, Dixon. Go ahead.
Cam writes, "Hi, TWiP team. Congratulations on episode 200. A great effort. New South Wales, Australia, 21C, 69F, partly cloudy. To cut to a long diagnosis short, the intracellular protozoan parasite Toxoplasmosis gondii is my diagnosis. Reasons: show about parasitology, the most common answer in a parasite, the multiple mention of a positive source of infection, wife's cat, CD4 less than 100 via HIV, weak immune responses to parasites, ring-enhancing lesion often seen due to T. gondii infection. Many people with HIV/AIDS also have toxoplasmosis due to recent infection or a previous infection that has been reactivated. Blood tests to confirm the diagnosis should be done to check for the presence of antibodies to toxoplasmosis and/or PCR testing to detect and measure T. gondii DNA in the blood or cerebrospinal fluid, CSF. Treatment with trimethoprim, sulfamethoxazole, cotrimoxazole, and a plan to improve compliance with ART medications for HIV. Dapsone and pyrimethamine are an alternative combination for treatment, again, with improved compliance with HIV meds. Cheers, Mr. Ozzycam.
Wyatt writes, "Hello all, this is Wyatt, MS2 now in Loma Linda, and I'm happy to have a spare moment to write again. I have been diligently listening from afar and even gave a brief journal highlight on the article you all presented on the fungal killer of mosquitoes endowed with the venom of Australian spiders. I presented this to the infectious disease interest group here, and they loved it. Thanks for always recommending interesting reading. It has been great hearing from Dr. Naula as well. She is a great addition to the team. HIV patients who are not taking their medications are unfortunately at risk for many awful complications: PCP pneumonia, candidiasis, progressive multifocal leukoencephalopathy, JC virus reactivation, and countless others. The fact that this is TWiP and that it is affecting the brain with ring-enhancing lesions makes me automatically think toxoplasmosis encephalitis. This can present in many ways, but having focal neural findings is common. The tasteful addition of the family cat in the history was also helpful in the diagnosis. A cysticercosis of tinea solution would be in my differential as well. I might also consider a CNS lymphoma, but there would not likely be as many lesions. I'd also like to check out the coating on the man's tongue and maybe do a scraping to check for oil candidiasis.
Right.
To treat the toxoplasmosis, I would give pyrimethamine and sulfadiazine. All the best from ever sunny California. Thanks for all you do, Wyatt." Dixon.
Anthony writes, "Hello again. The lesions on the brain for this case study has me tied 50-50 between progressive Balmuthia mandrillaris infection and a really, really bad toxoplasma flare-up. The mention of cats and HIV-1 leads me down the toxoplasma route. Hopefully so as it is a ton easier to treat, Bactrim and clindamycin, than a progressive Balmuthia infection." Anthony.
Christina.
Ken writes, "Dear TWiP team, greetings from Indianapolis in the Hoosier state." I hope I pronounced that correctly.
Hoosier.
Apologies.
No
First and
problem.
foremost, thank you all for your wonderful work and contributions. I consider myself a fairly new viewer, listener of TWiP, TWiF and TWIM and Immune. I've started listening to your podcast over the last year and have been addicted ever since. Excited to be writing in my first guess. I am a CPEP clinical microbiology fellow, and these case studies are a great exercise, learning tool, and alternative to my usual work commute, carpool karaoke. On the case, given the clinical presentation of our HIV positive patient, CT and MRI results, his low CD4 count, and a history of living with a cat. My guess is that this patient may be positive for toxoplasma, possibly acquired from dealing with the cat's fecal matter. I would also venture a guess that the medicine he had neglected to take may included some form of prophylactic treatment. Look forward to hearing the answer to the case. Hope you all have a wonderful Christmas holiday. Kind regards, Ken.
Daniel.
Scott writes, excellent TWiP 200. It was almost like you were starting a podcast on ecology. TWiEcho has a nice ring to it. So this is my first go at a TWiP diagnosis, and I think Daniel gave me even enough clues to get this one. My diagnosis for the HIV/AIDS patient is toxoplasmosis. While the brain lesions could be caused by multiple bacterial or fungal infections, this being TWiP, I went to toxoplasmosis. Toxoplasmosis is a common cause for brain lesions in AIDS patients. The toxoplasma parasite probably came from the patient's wife's cat. Serological testing for anti-toxoplasma antibodies should confirm the diagnosis. Steps going forward. Treat the toxoplasmosis. The CDC website says patients can be treated with a combination of drugs such as pyrimethamine and sulfadiazine plus folinic acid. Encourage the patient to regularly take his anti-HIV medications. Find out what are the underlying causes of him missing doses. If it is truly just forgetfulness, maybe an app or a person that regularly reminds him will help. Toxoplasmosis is one of many infections this man is at risk of contracting and dying from. He already appears to have a bad case of oral candidiasis or thrush. A systemic infection from Candida or other fungus could be lethal. Tell the patient to avoid the cat's litter box. There may be ways to limit toxoplasma exposure from the cat by limiting where it goes and where it goes to the bathroom. Also, would treating the cat be helpful? Glad that most of the TWiP gang got together. Maybe in the not-too-distant future, you can road TWiP to Glasgow. I like that.
Very good.
Best regards,
That's a good
Scott.
plan.
Yeah, we'll come. But if we go to Glasgow, Christina, we have to have scotch.
Absolutely.
Yes, that's absolutely fine.
Yes, it'll be a airplane road TWiP.
Exactly.
Dixon, you have the last one.
Matt's writes, Dear all, sorry for short answer. Headache plus fever plus CD4 below 100 and ring-formed lesions in the brain sounds like cerebral toxoplasmosis. Serology might only yield positive IgG, but PCR from CSF can give confirmation. Non-parasitic treatment includes cytomegalovirus, PML. Please remind me what that stands for.
Progressive multifocal leukoencephalopathy.
Oh, that was so good.
Thank you, Vincent. Cryptococcal meningitis and CNS lymphoma, among others. Thank you for a great show. Best regards, Mats. Okay.
All right. Well, folks, I have to not hear you guys, but the folks out there in the audience, you need to step up your games. Not enough guesses.
True.
But we have guesses, better than nothing.
And we've got lots of signed books.
Yeah, now the books are all signed. At 200, Daniel and Dixon came here and signed them, so we're ready to go out.
Yep.
So, what does that bring us?
Well, we have three more guesses, right? Who should we start with?
Christina,
you go first.
Yeah, start with me. Actually, it was a really funny coincidence because on that day that we did the TWiP, I also recorded a lecture with a clinical colleague on opportunistic infections in HIV patients.
Oh, brother.
And discussed a case that was very, very similar. So I think, I mean, he has quite a low CD4 count. And I think with CD4 count under 100 or 200, you should really always consider toxoplasmosis. Other ones, cryptosporidiosis, but that's not a parasite either. It's not, is it? No, sorry, getting my pathogens muddled up.
Dixon, do you consider cryptosporidium a parasite at this point?
Cryptosporidium is considered a parasite, but I don't think it's considered a parasite of this patient. Let's put it that way.
Do you know what? I've muddled it up with Cryptococcus.
Yes. So Cryptococcus,
Cryptosporidium would have been a good guess if he had drank some contaminated water.
Yeah,
true.
it's late here in Glasgow, so
And we are told that large glass is tea and not scotch. So, but we're
That's right.
we're
That's
now
right.
taking that with a grain of salt.
Exactly.
I'll hold it up for the viewers.
Please.
It is tea. Yeah, so my guess is firmly on toxoplasmosis as well.
Okay.
And yeah, that would be my guess.
All right, Dixon, shall we let you go next?
If you wish, but I taught this course at Columbia, as you well know, for 38 years, and we always included this in our differential diagnosis for HIV, and when it was apparent, because I started in 1971 prior to HIV outbreak, but after the early 1980s, this was always included in our differential. So I am obliged to agree with the masses and say toxoplasmosis is a very reasonable assumption in this case.
Yes, I agree. Ring-enhancing lesions, cat.
Yep.
Immunosuppressed, toxoplasmosis, yeah.
Yep.
Okay. Well, I appreciate the emails because it was nice the way people brought sort of the differential here, and hopefully there were a lot of the helpful bits of evidence, right? So the CD4 count below 100, that's one of our critical toxo risk factors. Now, often when we see a patient like this, and something we see quite often, I'll say we saw much more often in the early days, when we see the ring-enhancing lesion, that's really our big thing. We're thinking toxoplasmosis, but CNS lymphoma is also in there, can present in a very similar way. And I think the other differentials were important as well. What we will often do is we'll go ahead, we might check a toxoplasmosis antibody, but we'll often treat and then see if they respond. And if they respond, then sort of a therapeutic confirmation that we're doing the right thing. If we do not see improvement, then often we may actually do brain biopsy, worried about the lymphoma as the alternative diagnosis. But no, in this case, the serology was positive. Patient was started on treatment. We saw improvement. This individual, fortunately, went on to actually start taking his medication on a regular basis, not only his prophylactic, but also his antiretroviral therapy. Actually, fortunately, did quite well. When I saw him later, there was no residual weakness in the lower extremities. He actually really did quite well. So sort of a very nice, positive outcome. But I thought, should we talk a little bit? I thought it was interesting in the history. Like I sort of enjoyed his religious background, which prompted him to only eat well-cooked meat, and sort of this connection with the wife's cat. So I don't know, Dixon, do you want to talk a little bit about the litter box and the risks there?
Well, sure. The oocysts of toxoplasmosis, and the cat is the only definitive host. First of all, let's just start with the life cycle. As the cat ingests the pseudocysts from, let's say, a mouse that's not a definitive host, but an intermediate host, and carries the infectious stage for the cats and also for people. If we were to eat a rat or a mouse by accident or on purpose, we would only acquire the asexual stage of the parasite. But the cat acquires the sexual stages of the parasite as they evolve in the gut tract of the cat. And then mating occurs, and they form the zygote. And the zygote develops into an oocyst, which has two organisms encased in a thin membrane. And that then passes out into the environment. And when that's eaten by another animal, it initiates infection. But the infection that occurs in those other animals, of course, is not the sexual, but the asexual stages. But the oocyst can last quite a while in the feces of the animal before it dries out. So they have developed litter box contents, which actually dries out fecal pellets so fast, sort of like the little packages of the drying agents that they put inside certain drug containers to keep the moisture out. This litter material absorbs the fluid from the cat's feces, and the oocyst inside the cat feces then dries out, and when they dry, they die.
Yeah, let me
Was that
ask.
too much?
No, that was actually excellent, because it brings me to this question: like, is it better to be changing the litter box every day, or is it better to be using, the litter that has this desiccant in there, so that by the time you change it?
I think if you're smart, you'll handle it as few times as possible, and it takes a long time for this to become saturated, so it doesn't work anymore. So they even have automated pellet removers that's sort of like a big rake that rotates through the litter box, and it's got a mesh, a distance between the tines, which allows it to grab all of these hardened fecal pellets, and they're removed automatically. So it's quite amazing that we've advanced so far in preventing toxoplasmosis transmission in the home that there's probably no excuse for not having one of those.
So, Daniel, would it make sense to treat the cat?
So that's an interesting concept. Like we don't really go there, right? We don't necessarily treat the cats, but maybe it's not a bad idea.
There was a gentleman, as we well know, his name was Elmer Pfefferkorn. He was one of my heroes, who developed a way of actually vaccinating cats against toxoplasma. He used a temperature-sensitive mutant of toxoplasma that could always replicate in the skin and passed antigen into the deeper tissues, of course, for processing. And he was a very clever man, and it was a good vaccine, and I'm not certain whether it's still available or not, but at one point it was commercially available.
But of course, if you treat the cat and then it goes out again, it's just going to be...
Or often we'll give it scraps,
exactly
right? We'll be
a vaccine is a much better idea, I think.
Yeah, so vaccines, you don't have to keep retreating. But
I think the real solution is to have well-cooked cat.
I believe deep fried.
That sounds like a W.C. Fields solution.
That would be Mark Crislip's solution.
Yes, I think Mark Crislip.
Well done,
cat.
cat.
Agree with that.
Well done, cat.
All right.
That's fine.
Well done. No, we'll leave the kitty alone. That's fine. All right, it's time to give away a book. We actually have signed copies.
We do.
To get to you. So we have 9 guesses. Let's see what we get. I'm going to pick a random.
Want a drum roll?
That's right. Go ahead, Dixon. Number 2. Who's number 2? Let's see.
Is that Michelle? Do we have that right?
Michelle.
Yeah, it was Michelle.
Michelle, you are the winner. If you would like an autographed copy of Parasitic Diseases, what is it, the 7th edition?
Yes.
Please
Fabulous.
Email your address, TWiP@microbe.tv. If you are out of the U.S., I also need a phone number. TWiP@microbe.tv. Congratulations. And we'll move onwards.
Okay.
Terrific.
Now we have, Christina has prepared a paper for us, right, Christina?
This is
I
good.
have, yes. Yeah, I have. It's so it's on Leishmania, which is a parasite that I used to work with in the lab. So I always enjoy returning to it. But actually, I was triggered to look at that paper because I was preparing a tutorial question on preventing outbreaks of leishmaniasis or bringing them under control. And I kind of been reading a little bit and I came across that. So the paper is called Domestic Mammals as Reservoirs for Leishmania donovani on the Indian Subcontinent, Possibility and Consequences on Elimination. And actually is a review article, so it's not primary literature, but it's got lots of interesting discussion points in there. And the first author is Kushahava, and the final author is Peterson, and they're affiliated. I think let me check where the first author is in Banaras Hindu University in Varanasi in India, and the corresponding author is in the Center for Emerging Infectious Diseases at the University of Iowa.
I love the name of this journal.
I know, it is amazing, isn't it?
Transbound emerging diseases.
In fact, I've actually read quite a few papers from this journal through my MSc program in One Health that I also teach on.
Wow.
And it's got so many, transboundary really, essentially. Got so many very varied.
What does that mean?
Is
that basically
just across the boundaries, I would say? That's how
Parasites Without Borders, are you saying?
Pretty much, yeah.
Okay.
So I think for that we maybe need to just kind of think a little bit about leishmaniasis, because actually leishmaniasis is a really complex disease. It's a disease complex. It's just very complicated. So we've got many different species of leishmania, and we've also got 3 different forms of clinical presentation. So I I'm not sure. I think maybe we can refer people to the TWiP where you were discussing the ins and outs of leishmaniasis. I think it's very early on for the details, but I'll maybe cover a couple of bits. So maybe focusing on visceral leishmaniasis. So this is caused by different Leishmania. I don't know if I should call them. I'm always a bit anxious about calling things strains and variants now, Vincent, because I listen to TWiV. So I think we can go with strains, but please correct me if you don't think that's the case. So visceral leishmaniasis can be caused by Leishmania donovani and Leishmania infantum. And so it depends a bit on where in the world people live. So Leishmania donovani is the causative agent of visceral leishmaniasis on the Indian subcontinent, but also in East Africa. And Leishmania infantum is also kind of around the Mediterranean basin. They are very, very closely related, those two parasites. And then in the Americas, the primarily visceral leishmaniasis would be caused by Leishmania infantum.
So, Christina, those are actually species, two different species.
Species, yes.
Yeah, so
yes.
you're good.
Yeah, so I'm okay.
You're off the hook.
Yeah, I think they are in the same species complex. So Leishmania infantum is in the Leishmania donovani species complex. Yes.
Christine, is there any difference between New and Old World disease?
I don't think so. I think the transmission, the ecological context is really very different, but I think clinically they're quite similar.
Yeah, different vectors. That's right.
But maybe Daniel, you would want to jump in on the clinical side.
I think if we're talking about visceral leishmaniasis, the manifestations can be pretty similar. The big difference would be when we start getting into cutaneous and mucocutaneous, right? Which we're going to see as more of a new world disease, right? So the cutaneous is actually quite common through Central and then down into South America. And then there's certain subspecies, so the Viana, which is where we're going to see the mucocutaneous at different frequencies depending on which subspecies. So the Brasiliensis, the Panamensis, there's certain ones. All right.
Yeah.
And, actually, we should talk about the two different sandflies. And,
yes, I was just about to say that. So actually, the sandfly that this paper mostly deals with is Phlebotomus argentipes. And in the Old World, so in the Mediterranean basin and in Africa and on the Indian subcontinent, is always Phlebotomus species that transmit Leishmania. And in the Americas, it would be a Lutzomaya sandfly species. And, the types of sandflies might well have an effect on the transmission. So I think the ecology of the disease is actually really complicated. So it maybe depend on the ecological interactions between people and reservoir systems and parasites and sandfly species. And maybe also present and past susceptibility in humans and animals, and also human behavior. So, maybe people sleep outside, so they may be more susceptible to sandfly bites. But then other aspects that maybe play into it is kind of unplanned urbanization, but also malnutrition. So lots and lots of different factors to consider. But visceral leishmaniasis is endemic in 98 countries, and that's almost half of all the countries in the world. So it's really, really quite widespread. And the hotspots for visceral leishmaniasis are East Africa, the Indian subcontinent, and Brazil. And this paper really focuses on the Indian subcontinent. Now, for visceral leishmaniasis, we've both got anthropootic transmission, so transmission from human to human via the sandfly, but also zoonotic via reservoir hosts, particularly dogs. But that would be then different species of Leishmania. So zoonotic transmission is generally Leishmania infantum, and like Leishmania donovani has always really been considered mostly zoonotic, and that's also really how elimination programs in the Indian subcontinent have been planned around. So it's really based on the fact that there is no zoonotic host. And actually, that maybe a couple of words about that eradication program. So this is quite a large area in the north of India, also Nepal and Bangladesh. And there's a national mandatory elimination program. And visceral leishmaniasis has become a reportable disease in, I think, in 1992 or somewhere thereabouts. And it was really based on early diagnosis and complete treatment and vector management and surveillance, etc. And it's been remarkably successful. So there's been a 97% decrease in cases really from 1992 to 2020. So that's really, really remarkable. And what they mean by, so they call it an elimination program, but what they mean is really that there's less than one case per 10,000 persons that would be considered successful. That's the kind of markers of success for that program. And actually the deaths have also been remarkably decreased. So I think in 2020 there were only 37 deaths. But, there seem to be some areas where that are still being considered endemic, and I think that's where that paper came in really. So they were kind of trying to think, what other. I'm just trying to find my way through my notes. So they were kind of trying to think about other potential infection sources that could maybe, prevent the elimination program in these remaining endemic areas to be really successful. So they were discussing asymptomatic or, persons that might be contributing to transmission, and it could also be post-Kala Adar dermal leishmaniasis. That's obviously lesions. The lesions in this case are really, so this is really, this is something that happens after successful treatment of visceral leishmaniasis, maybe a month or a few months later, that you will have a cutaneous manifestation. And these lesions in these patients are really full of parasites, so they will contribute to transmission. And then the other thing that I look at in particular in that review article is zoonotic transmission, because we know other Leishmania species can be transmitted zoonotically. So
yeah,
I was going
to jump in, Christiane, because I think the post-Kala Azar dermal leishmaniasis is pretty interesting, and a lot of people think of this as really important, right, in the human to human spread. So here are these individuals, we think we've treated them, right? Sort of the idea, we think it was successful, but then they come back about a month later or so, and they have this papular nodule rash on the body, and they are just teeming. And so this is just an incredible source. So there's been a lot of, when I was in India, there was a lot of discussion about you really want to identify these people and do not let them get bitten by sandflies, get them treated. Because it may be like, I sort of think of the parallel with the female Anopheles, the double biter, that 1%. This may be the 1%ers that are really important in the spread. We talk about the 80-20 Pareto principle, but this is really maybe the 99-1 principle, at least the idea just how teeming these individuals are.
And it's actually quite surprising. So PKDL was only really taken into this elimination program much later. So, these cases are now also thought out in surveillance and treated. But actually, this has been known for a long time, and it's a bit surprising, really, that this was not considered from the very outset. But in this paper, particularly, they looked at asymptomatic and zoonotic transmission. So I looked at a couple of the papers that they discussed. So one in particular that caught my eye, and so where they were actually trying to assess whether asymptomatic or people would be transmitting or would be able to transmit the disease or the parasites onto sandflies and then onwards to a further patient. And they looked so they did a prospective xenodiagnosis study in that same region in Bihar in India, and they used visceral leishmaniasis confirmed cases, also PKDL patients, and asymptomatic cases. Although I'm always a bit unsure what, maybe they have quiescent parasites or persisters. So it's quite complicated, but for the purpose of today, that's probably
Christina, you
enough.
might want to explain to the audience what a xenodiagnosis is.
I was just going to come on that. So what they do, so they in this particular study, they would expose the participants' forearms and lower eggs to quite a few sandflies. So I think it was 30 to 35 female sandflies for 30 minutes. And then they would take the sandflies, they would keep them in a cabinet in some kind of insectary for a while so that the parasites could differentiate. And then the flies were dissected and evaluated for infection by microscopy and also quantitative PCR. And what they found, really just to cut a long story short, is that essentially the people who were not symptomatic but were shown to be positive for Leishmania infection, none of them were infections to sandflies. So I thought that was quite interesting. Whereas of people with active visceral leishmaniasis and with PKDL, so there were 55% were infectious to sandflies and 42% respectively. So that's quite a difference. So I think from that paper and others that were discussed in the review as well, we can maybe think that that's maybe not a possible infection source that may prevent the elimination program from failing. So maybe not as relevant as they thought it might be.
Yeah,
so
I
then
thought
they moved
that was fascinating. Like I actually, maybe I'm a visual learner, so I really liked figure 3, where they sort of break this down, and where you've got your asymptomatic folks, not really, thinking that they're much of a risk, so classified as low risk. The visceral leishmaniasis is high risk, but then they even break down the dermal into the nodular papular. They look like high risk, but the macular, really more of a medium risk. So sort of getting a little more subtleties here as far as the, human to human or human to sandfly to human transmission to be.
So I think that was the first kind of take-home message, that they thought, well, it's probably not asymptomatic infection. And they started looking at zoonotic infection. And I'm going to just have to try and find the right paper now. There we are.
Has anyone been bitten by a sandfly here?
Yes.
I don't know. Maybe.
maybe.
I don't know. I've been in the Mediterranean, so I don't know. I don't know.
Because it looks like the proboscis is pretty scary, that serrated thing.
Oh, they're very delicate,
really, really
very
tiny.
gentle. Really? Yeah, I'm sure I've been. It's just a question of how often in places where I go. But this is one of those things when I hang my hammock, right? So I don't know if people know this about the sandfly, but they're really more jumpers. They're not tremendous flyers, right? They're not like your tsetse flies. They're not perched up there in the tree like hunting you. And so you always measure to make sure your hammock is 18 inches off the ground is our idea. But I feel like this might be like towel off figure or something when I swim in Lake Malawi. But yeah, getting up that actual height theoretically keeps you a little bit protected from the sandflies. But these are not painful bites. These are like, let's say you're river rafting and you notice there's some of these, they are beautiful, little delicate insects.
They're tiny and hairy, really quite pretty, really, really hairy.
Hairy in a pretty way.
We refer to them as the wimps of vectors.
They're also not very. They can't fly very far either. So
that's why they breed right around the burrow holes for a variety of wild animals. They don't have to go very far for their meals. So I'm wondering which domestic animals that these people jumped into to try to show a correlation.
Well, so actually, there's a table in that review that lists lots of studies where they've been looking at evidence of presence of Leishmania donovani in particular in India, Nepal, and Sri Lanka, and Ethiopia, and the Sudan. And actually, they do find evidence in livestock, so cattle and goats, but also dogs and
Dogs
rats.
were always
and
known,
rats.
though, right?
And yes, but Leishmania infantum. So I think it's a very, I mean, it's the major reservoir host in Brazil, really.
Mm-hmm.
And a lot of dogs are infected. So I've looked at a few papers that were in this table, and one that triggered my interest was a study that was from a different part in India, so further south in Kerala. And that becomes relevant in just a moment. So there's a tribe there, a very remote tribe, and they actually suffer from cutaneous leishmaniasis caused by Leishmania donovani. So, which in itself is really, really interesting, because it's it's traditionally a causative agent for visceral leishmaniasis. But actually, also in Sri Lanka, there is cutaneous leishmaniasis, which is also caused by Leishmania donovani, and they're geographically, these regions are quite close, so maybe there's a connection there. But anyway, so there in that tribe, in this paper, they looked at 47 dogs, and they were all asymptomatic, so they didn't have signs of leishmaniosis. So actually, in Brazil, the dogs that are infected with Leishmania infantum, they are quite sick. So it's a systemic infection, and the dogs look really poorly and miserable. But these dogs, they seem to be just fine, and also didn't have any cutaneous presentations. And what they did, they sequenced the genomes of these parasites in the dog, in the people, and also in the vector, and they were identical in sequence. So from that, one can maybe, it's a very small study. There were very few cases, but that is probably quite conclusive evidence that a dog in this particular situation is a reservoir host. But then other studies that looked at are much less clear cut. So most of these studies have actually seen parasites in dogs or rats or other rodents, but they haven't actually demonstrated that these are transmitted. So they haven't done transmission studies. So it's really only that paper that I thought was quite conclusive in demonstrating that there might be, and maybe in a small region that might be. So zoonotic transmission of Leishmania donovani might be possible, even though we think it's generally anthropogenic, so between people. So I think the conclusions really are that I think really to have successful elimination strategies, we probably just need to get a much, much better understanding of the epidemiology and the transmission dynamics to really get to those last, to really get to that last mile, because there may be different factors at play that we haven't really taken into consideration. Particularly in Bihar at the moment, this elimination strategy only considers humans as reservoirs, but maybe, one might consider an epidemiological study in those areas where they have not been able to bring the numbers down as successfully. It could just be a public health issue, but it would be interesting to find out.
For viruses, if you want to eradicate them, you cannot have a non-human reservoir host. So for smallpox,
That's right.
poliovirus, no non-human hosts are known. Measles also, so they're all eradicable.
Yaws.
But SARS-CoV-2, no.
So particularly in dogs, you can prevent infection by the dogs wearing like flea collars. I'm not actually sure if dogs are treated, but I just thought about that when we mentioned the cat earlier. I don't know.
So that's a question I wanted to ask you. So if you find out that dogs, cattle, goats, if they are infected and they do serve as a reservoir, what can you do? You can't eradicate it in them, right?
I can tell you what they did in Brazil in the 1990s. So there was a big drive to cull the dogs. as many dogs as they possibly could. But that was actually not successful in the long term because people replaced the dogs very quickly.
Sure.
And then, with puppy dogs are more susceptible to infection. So it really didn't drive the transmission down at all. So I think culling is probably not the best thing, but prevention of infection, maybe by keeping your dog, inside the house, maybe use indoor residual spraying, or have little mesh in the kennels for the dogs, and use flea collars. That might be better. I'm not sure about cattle and goat really, but you could just remove them. Really, not have them right next to your sleeping quarters, just outside your bedroom window.
No, that sounds easy, but you think about
it's not so easy,
cows in India, right? I mean, the cows sleep indoors. The people sleep outside.
Yeah.
I mean, it's
Wow.
So I think actually there's a lot of sociocultural factors that you'd have to consider as well if you wanted to prevent transmission.
And
but
the
we don't
dogs,
actually
right?
know.
A lot of times the dogs are just sort of roaming around and.
Yeah.
I'm really quite surprised that this study has risen to the level of a paper, because I know that since this was discovered back in the late 1800s by Leishman and Donovan separately, and then Sir Ronald Ross put them together and named it after both of them. By the way, both authors never spoke to each other. Leishman and Donovan, they didn't like each other. Since that discovery, I know that there have been thousands of studies to find out the range of hosts for Leishmania donovani, and I can't believe that this hasn't been reported prior to this paper. That's my big surprise here.
There's a lot of very little studies, and oftentimes they are published in maybe not so well-known journals, and maybe not cross-reference journals, so it might be just quite difficult to get that information together.
Yeah, maybe, but there was such a concern for it during the Second World War, because we were stationed in India, and I don't know if you recall this from your history, but we were trying to fly over the Himalayas in order to get to the Japanese emplacements in many parts of Southeast Asia, and many U.S. troops were stationed in India, and a lot of them came down with this infection. So there was a big presence. Wasn't as prevalent as malaria, but it was certainly looked at, and I'm sure they did host studies on these things, and maybe that's buried in the U.S. medical literature.
Maybe.
But
I think it's quite difficult to tease that epidemiology really apart. Because
that's why I think it's an ongoing study. That's exactly right.
It's also hard to think
that
about.
Vector phlebotomus argentipes that actually feeds just as much on cows and dogs as on people. So it's a very indiscriminate kind of biter.
That's true.
So So, but I don't know. I mean, the take-home message is that we don't really know whether zoonotic transmission does play a role in keeping, these endemic areas endemic, or or whether there may be other factors at play, like maybe issues with public health, or maybe these are particularly remote areas. Although I think this elimination strategy has been really efficient in reaching even the smallest rural. So they have kind of decentralized.
Well, the indiscriminate feeding habit of this phlebotomous species is the biggest determiner, because you can certainly warn people about when you should go out and when you should stay home. These are early morning and late evening feeders, but they don't feed all through the night, and so that you can adjust your diurnal rhythms basically to avoid being bitten for the most part. And that's been done in many places throughout South and Central America. I remember Suzanne Holmes Giannini, one of the members of our faculty, talking about the chicle gatherers in South and Central America from the chicle trees to develop the contents for chewing gum. And the early arrivers at the chicle trees were the ones that usually came down with leishmaniasis, whereas the ones that went later on in the day, they got less chicle, but they didn't get any leishmaniasis. So there were all these weird studies. But I can't believe that in, let's say, the 80s and the 70s and the 60s, that someone didn't do an experimental set of infections in a variety of animals just to see what the host range was for this parasite. And,
I think the host range is pretty wide, but
it is pretty wide.
how much they are actually involved in the transmission
Well, that's the
cycle,
point.
that's a
That
bit
is the
more
point.
difficult to determine,
That
I
is the
think.
point. That's
Actually, I
the
think
point.
these parasites are just so amazingly interesting. I briefly mentioned those Leishmania donovani causing cutaneous leishmaniasis in Sri Lanka.
Yeah.
I mean, it's, we think Leishmania donovani, we always automatically think visceral leishmaniasis, and it's just really fascinating. And actually, that is it's the same cymodine in Sri Lanka that is causing cutaneous leishmaniasis, but causes visceral leishmaniasis in Ethiopia. So, there's so much at play that we don't understand.
A lot of host factors we don't understand. That's true.
But I should probably not get into that rabbit hole because otherwise we might be here in 2 hours. But yeah.
All
So
right,
that's my review paper.
Nice. Thank you, Christina.
There was
thank
a
you.
lot of discussion.
Yes, probably a bit of information overload.
It's okay.
Not at all. Not at all.
So, Daniel, what is up with our next clinical case?
So the next clinical case is a little bit exciting. We are going to have a special guest next time to do the unveil. But this case was presented ahead of time, so I've got the case now. I'm going to share it, and then when we do the unveil, we will have a guest. They're going to visit us here at the incubator and help with the unveil.
Are you going to come here as well, Daniel?
That's the plan.
Okay, very good.
Okay, so are we ready?
I'll try to make it too.
Okay.
We are.
You're going to make it too, Dixon. Okay, this is exciting.
I'm going to do my very best.
Okay, so this is an older male. I will say greater than age 65. That's sort of the cutoff. I guess that's when we become old. Who has been having abdominal pain over the last several months. It seems to be progressively getting worse. Otherwise, he feels well, right? So this is really this progressive abdominal pain. There's no change in weight. He doesn't have any other concerning symptoms. His past medical, his past surgical, family history are all unremarkable. But now his social history. He grew up in rural inland China, far from the coast. But then as an adult, he moved and lived in a large city. He reports he was always very active and healthy, swimming, eating fish, leafy vegetables growing up, continues to do that, continues to try to stay healthy. Now, he moved to the United States about 10 years prior to this presentation. He has returned back to mainland China a couple times. He does not have a pet. He was thinking of getting a dog with a really cool name, but decided against that. He does not own a cat, and nor does his cat that he does not own have an interesting and cool name, so no pets. He reports no toxic habits. He's not a smoker. He's not a drinker. We'll throw out he's HIV negative for Vincent over there. He has an unremarkable exam. So now we're going to jump to his lab work. So he has some blood work done. People are not sure what's really going on here. He has an elevated white count, greater than 10,000. His platelets are a little bit low, down a little bit over 200. He is not anemic. Otherwise, normal chemistries, electrolytes. The differential we got on that white count was neutrophil predominant with an absolute eosinophil count of 290. So that's within the normal range, less than 500. He doesn't have any elevated total bilirubin, transaminases, alk-phos. A bunch of serology, HIV is negative, hepatitis B, surface antibody negative. So far, so good. So far, no answer. But he goes ahead and he gets a belly scan, a CT of the abdomen. And this reveals a mass in the colon. So he goes ahead and he has a colonoscopy. There are multiple biopsies done, and then they actually resect the mass. So I want people to think at this point, what might we be thinking about in our parasitic world? But I'm going to give you a little bit of the pathology. So the pathology comes back. It shows cancer. It shows an adenocarcinoma, but there are also eggs in the sample. All right. Any thoughts? Any questions? Are we good? Do we feel like we have enough here?
Is he living alone? Living alone?
Yep.
Okay. Nobody in the house, just him.
Just him.
Any sexual habits?
No, he just, he was heterosexual and nothing. Currently is not sexually active, has not been sexually active for a while. It's a good question.
His fish eating habits, did he eat cooked fish or raw fish?
Both.
Both.
This
that's a tricky one.
This carcinoma was
incidental.
Removed. What stage was it? Do you know?
I do not know. We'll probably be able to find out from our guest.
Okay.
My first question when I heard this was I wanted to know the size of the eggs, which I thought would be helpful. And they
Maybe
are...
a picture would have been even more helpful.
Yeah. So they are slightly...
Are you going to share a picture?
No, but I will tell you they are slightly ovoid and about 80 micrograms.
80
micrometers, I guess.
Micrometers.
Microns.
80 microns.
Yep.
In length.
80 microns. Not micrograms, microns.
So the eggs are in the cancer
You can actually
tissue?
see them in the tissue. Yeah.
Okay. And there are no eggs elsewhere in the colon, just in the
tissue. They're
the
actually
tumor.
in the tissue.
Wow. Okay.
I think I'm good.
Yeah.
Was it that last bit? Was that what really got you?
Probably.
Yeah. And some of the history.
Okay.
I mean, I might be completely wrong.
A picture would be worth 1,000 words here.
Yeah.
Yeah, you can't
See,
have
I've been looking at parasite eggs all week this week.
So you're ready.
I'm ready.
The 80 microns ring a bell?
Yes.
Excellent.
But that's not the only,
Yeah, that was my
quite a
question
common
was
size
like,
range, isn't
so
it?
were those
Yeah.
eggs about 80 microns? And I was like, okay, now I feel good.
Oh, okay. There you
So-
So
go.
Vincent,
we'll see.
I have a hero that we didn't get to.
Oh, okay.
It was on my other computer, unfortunately, so I will send it to you and you can paste it in.
Okay. Who's your hero?
Well, I'm blocking on her name right now, because I don't have it in front of me. It's
Well,
on my
maybe
other
you
computer.
should leave it till next time,
Okay, fine. I'll do it the next time.
because
That'll be
the
fine.
hero deserves some mention.
Oh, absolutely. Absolutely.
It would be good.
So this was an early 1920s graduate who ended up at NIH in her career, and she discovered a lot of basic parasitology for schistosomiasis and pinworm and all kinds of other things during the halcyon days of the opening of the NIH.
All right, bring it next time. Do
I
we have a
will.
date for the next one, Daniel? I think we do,
Yeah,
right?
it's in January.
We do, actually, yeah.
It's January, right?
Yeah.
Okay.
Yes.
Let's see if I can tell people so that...
It's going to be January 13th, so people have a little bit of time over the holidays, and then we're going to have our guest come here to the incubator, and it's going to be very
what time
exciting.
is the TWiP on the 13th?
So it's going to be at 4 o'clock, so we're doing TWiP early. And I'll record my TWiV update afterwards. So this...
So this is Monday, the 13th of December.
Yes. Oh, no, of January. January. So it's a little bit of
January.
time.
Sorry.
So we got plenty of time. I expect a deluge of letters and guesses.
So the 13th is a Thursday. Yeah,
Thursday.
it's on my calendar already. Very good. All right. That is TWiP 201, microbe.tv/TWiP for the show notes. The case guesses, go to TWiP at microbe.tv. If you like what we do, consider supporting us. If you go over to parasiteswithoutborders.com and donate, they will match your donation and give it back to Microbe TV, the parent company of TWiP and all the other podcasts. Parasiteswithoutborders.com. You scroll down a little and there's a button that says donate. Daniel Griffin is at Columbia University Irving Medical Center and parasiteswithoutborders.com. Thank you, Daniel.
Well, thank you. Always a pleasure.
Good to see you in the incubator. Dixon Despommier is at Racaniello.org and thelivingriver.org. Thank you, Dixon.
Pleasure.
Dixon, on the last TWiV, which you were not at, I think.
I thought it was.
Or maybe the one before, someone complained. Maybe the one on Tuesday.
Oh, yeah. I remember
They
the one about
complained.
Gilda Radner and the couch thing, the confusion.
They don't like that?
No, they said you were confusing her with Lily Tomlin.
No.
Anyway.
That's all right.
And also someone said, I keep saying thelivingriver.com, but it's thelivingriver.org. And they said, I
.org,
should
that's
know
right.
because I built the site. And I said, okay. Christina Naul is at the University of Glasgow. Thanks, Christina.
Thank you very much for having me.
I'm Vincent Racaniello. You can find me at virology.ws. I'd like to thank the American Society for Microbiology for their support of TWiP and Ronald Jenkins for the music. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP
Is